So let's look at what happens when we have a different expression. And let's see if we can discover when the non-permissible values occur. So when we look at this value of 8 over x minus 1 and x plus 2, just plug in the value of 3. So we would have 8 over, we would put the 3 right here, and then we put the 3 right in that spot. So we would get 8 over, now 3 minus 1 is really a 2 times 5 is 10. Not really a problem. There's no issues there. Reduce if you want to. 4/5. All right, what happens if we put in a 2 in the next column down? We would have 8. This would become 2 minus 1 and 2 plus 2, which was 8. And this 2 minus 1 is a 1 times 4 is 4. Answer's 2. Let's keep going. What happens if we put a 1 everywhere there's an x? That becomes 8 over. Now 1 minus 1 is 0 times 3 is 0. All of a sudden, it's not defined. Shucks. That's a problem. Now, we could try to look ahead without actually doing all the math and try to see, is there any other place, any other of these values of x along the left-hand column here, is there any of those that are going to create an issue with this expression? And the answer is yes. When we plugged in a 1 right here, it made this bracket 0. So what would we have to plug in to this to create a 0 on this bracket? And the answer is the -2. Let me show you how that works. So let's just skip some of those because we don't want to take all day long. If we plug in an 8, then we're going to plug in a -2 minus 1. It's not a problem in the first parenthesis. When we put them in the second parenthesis, you see how this is going to be 8 over -3 times 0. Oh my, that's a 0 on the bottom, so it's not defined. So I think maybe we can do one more on the right hand side and just check other values, because does it matter when 3, if I put the value of x is 3 here into this spot, I'm going to have 3 minus 3 on the top, and I'll put 3 everywhere there's an x, and I will have 0 over 3 times 1 is 3. That's not a problem. That's just 0. That is not undefined. Remember, it's when you divide by the 0, when the 0 is in the denominator, that we have not defined values. So let's just go ahead and plug in the 2. Another place, maybe I'll change color so that you can keep track of what I'm doing. So when I put a 2, I'll get 2 minus 3 over 2 times 2 minus 2. 2 subtract 3 is -1. And 2 times 0, that's not defined. So again, we have things that are not defined. So hopefully you're gathering that whenever I put in values for x that make a factor on the denominator be 0, that causes the whole denominator to be 0. So let's just show you what happens when I put a 0. If I go to this spot here, if I go 0, take away 3, and then 0 times 0 minus 2. The top is -3 in the numerator, but on the bottom I have 0 times -2, which, here we go again. This is not defined. So, long answer short, anywhere that you pick a value for x that the denominator will become a 0 is a trouble spot. And those are called non-permissible values. So let's just write a quick conclusion. For which values of x was it not defined? You could look back in the column. When x was 0, this was not defined. When x was -3, that would cause the denominator to become a 0. So that is a value of x for which it is not defined. Now for this third column here, there were 2 places. When x was 1 because 1 take away 1 would create a 0, or I should say and, -2 from this bracket. Both of those places are values for which the expression is not defined. From the last one, when it was 0 for here and +2, from here. All right, let's go and see if we can figure out some more information. It says usually results in C to make a connection between the rational expression and the values of the variable for which the rational expression is not defined. So I'm just going to say it's not defined when the value, makes the denominator 0. All right, let's see if we can practice. So state the values of the variable for which the following rational expressions are not defined. All we need to look at is the denominator, and if x was 6, that would turn into a 0, which is not defined. And for this other expression, it's just the denominator. So when x was a -5 from this expression and a 9 from this one, that would create as the denominator to be 0. All right, values of the variables that result in the value of a rational expression not being defined are called non-permissible values. So it just gives you an example here. This is 6, and this one would be -5 and 9. Those are called non-permissible values. If you want to write them as restrictions, restrictions are things that you cannot have, in which case we write them with a little symbol like x cannot equal 6. Those are called restrictions. So x cannot equal -5 and x cannot equal 9. Those are restrictions. Okay, non-permissible values. Here's a stop sign guy again. He's very important. Non-permissible values of a rational expression are determined by solving an equation where the denominator of the rational expression is equal to 0. The denominator is equal to 0. Factoring is required to determine the non-permissible values. So if they give me an expression and they just ask about non-permissible values, I only need to worry about the denominator. In order to find this, I'm going to factor the denominator, pull out what's common, leave what is remaining. And now that is the denominator. And from this expression, the denominator, I can discover what the restrictions are. This expression would turn into a 0 if x was 0 from here and +1 from this part. Now, since it says restrictions, I'm going to say what x cannot equal. All right, turn the page. So, to determine the non-permissible values, all you have to do is look at the denominator. We're going to factor the denominator every time. Always factor first. Notice I changed that to a +2 because a negative times a positive gives me back the original. From this expression, I can just look here and say the non-permissible value is x equals -2 because a -2 plus 2 would give you a 0. If I move to the second one, I'm going to pull out the p that is common to both. And when I do that, I get 4p minus 1. Now, this has two places right here. P being 0 would make it undefined. But also, what happens if this bracket is equal to 0? Well,